Now, let's proceed with the emulsion. So, alam natin that the base of the film is its foundation. It has a dimensional stability. Pag sinabi dimensional stability, kahit basain, kahit iwagayway, kahit baliin, it won't change its form. Our base is responsible for the structure of our entire film. So we know that radiographic film has two parts. Now we're done with the base, let's proceed to the emulsion. Emulsion is the heart of the radiographic film. It is where the X-rays or the light from our intensifying screen interacts. In the emulsion, it consists the gelatin and the silver halide crystals. Silver halide crystals is the active layer or the active ingredient of our film, especially in the emulsion. It is the active ingredient. The reason why we have gelatin on our emulsion is it will provide mechanical support for the silver halide crystals. It combines the silver halide crystals. So, pag sinabi natin gelatin, it is the same. The consistency is the same from the gelatin that we ate. Yung kinakain na gelatin, it's the same. So, the thickness of our emulsion is 3 to 5 micrometers. So, the shapes of silver halide crystal could be tabular, cubic, octahedral, polyhedral, or irregular. So, as kanina, di ba sabi natin that the crossover layer, yung mga light na nagpapass through, ang responsible doon is the shape of our silver halide crystals. Di ba kapag tabular grain yung ginamit, there will be a lesser chance of having a crossover effect. Kasi mas nako-cover niya lahat ng light na natatransmit ng ating intensifying screen. So, we can say that cubic, octahedral, polyhedral, and irregular are the shapes of silver halide crystals that could cause a crossover effect. There is an efficiency on how they will cover the light transmitted by our intensifying screens. So, our silver halide crystal, as I've said, is the active ingredient of the emulsion. So, silver halide crystals contains of silver bromide, it's composed of silver bromide and silver iodide. Our silver halide crystal composed of 98% silver bromide and 2% silver iodide. Now, these components have high atomic numbers. For our silver, its atomic number is 47. For our bromide, our atomic number is 35. For iodide, 53. The gelatin and base, its atomic number is 7. Now, why do you think that these materials have high atomic numbers? Because high atomic numbers, sila yung mas nakakakuha, mas nakaka-absorb. They can absorb the radiation. Tama? High atomic number absorbs radiation. So, the reason why we have silver halide crystals on the emulsion is that these are responsible for absorbing the radiation that will pass through the patient. So, the radiation that can pass through the thickness of the part under examination, that will form the latent image. Actually, I will discuss this on the latent image formation. So, ang sinasabi ko lang is that our silver halide crystals have high atomic number because they can absorb the radiation. So, tabular grains are used in most radiographic films. Flat and typically 0.1 micrometers thick with a triangular, hexagonal, or higher order polygonal cross-section. Tabular grains have 1 micrometers in diameter. So the arrangement of the crystals are cubic. So kung makikita natin dito sa picture, the arrangement of the silver bromide and silver iodide crystals are in cubic form. The reason why tabular grains are used in most radiographic films because mas malawak yung covering power niya para mag-absorb ng light. Okay? So, ngayon, tingnan natin kung paano ba nagkakaroon ng silver halide crystals. Specifically, the silver bromide. Paano nagkakaroon ng silver bromide? How is it formed? Okay. So, the silver is dissolved in nitric acid to form a silver nitrate. Again, this is the silver halide crystal formation. The silver is formed, the silver nitrate is formed by dissolving the metallic silver in nitric acid. So, meron na tayong silver nitrate. So, the light-sensitive silver bromide crystals are formed by mixing silver nitrate with potassium bromide. So, our silver nitrate is combined with the potassium bromide to form a light-sensitive silver bromide. Silver bromide and silver iodide are light sensitive. Light sensitive because we are using intensifying screen that form light. Okay, did you get it? So we have a silver nitrate combined with potassium bromide to have a light-sensitive silver bromide plus potassium nitrate. Saan po mapapapunta yung potassium nitrate kung nakakuha na tayo ng light-sensitive silver bromide? It will be washed away. Mawawala na siya. So, ganun yung nangyayari or ganun yung formation of silver bromide, of our light-sensitive silver halide crystals. So, these are formed with the correct pressure, correct temperature, and correct measurements of the chemicals that should be combined in the presence of gelatin. Kasi di ba gelatin provides mechanical support to our silver halide crystals. Okay? So, the number of sensitivity centers per crystal, the concentration of crystals in the emulsion, and the size and distribution of crystals affect the performance characteristics of radiographic film. Because our silver halide crystals can have an imperfection. The formation of silver halide crystals can have an imperfection. Kasi katulad nga na sinabi ko, our silver halide crystals are not perfect. There is an imperfection, and this imperfection is what we call the sensitivity center. It's what we call the sensitivity center or the latent image center. Diyan, sa sensitivity center na yan, nagkakaroon ng latent image formation. So, sensitivity center is a type of imperfection that is caused by a chemical contaminant, silver sulfide. Okay? Saan po manggagaling yung silver sulfide na yon? So, silver sulfide, it is from the combinations of our silver metallic chemicals or silver metallic and bromine and iodine. Kapag kasi nagkakaroon ng formation on these two chemicals, there is a releasing of an electron, of a positive and a negative electron. And this positive and negative can have a halide crystals. And these halide crystals are the sulfides. Okay? So the number of sensitivity centers per crystal, the concentration of crystals in the emulsion, and the size and distribution of crystals affect the performance characteristics of radiographic film. So first, uulitin lang natin yung mga characteristics of our screen film. So, dun tayo muna ulit sa contrast. We know that contrast depends on the size and distribution of silver halide crystals. High contrast contains smaller silver halide grains with a relatively uniform grain size. Low contrast contains larger grains that have a wider range of sizes. Sensitivity of the screen film combination to X-rays and light, that is speed. So for direct exposure, speed is principally a function of the concentration and the total number of silver halide crystals. For screen film, the silver halide grain size, shape, and concentration are the principal determinants of the film speed. So to optimize the speed, screen films are usually double emulsion. Double emulsion can double its speed. Recorded detail or spatial resolution. So this refers to how small an object can be imaged. A high-speed screen have low spatial resolution. Again, a high-speed screens have low spatial resolution. So, a fine detail screens have high spatial resolution. Fine detail screens have high spatial resolution. Large crystal size can produce a high speed. Kasi diba, silver halide grain size is one of the determinants of the speed. So kung malaki yung grain size, tataas ang speed. So large crystal size can cause high speed. High speed can have a low spatial resolution. Low spatial resolution give us low contrast. Now, can you get it? Large size can increase the speed of our film. If the speed is increased, we will have a low spatial resolution. Having a low spatial resolution gives us low contrast. That's why a high contrast can be obtained using a film that contains smaller silver halide grains with a relatively uniform grain size. Okay. So now we're done with the properties and the film construction. Let's proceed to the characteristic curve. So characteristic curve, these are two principal measurements involved in sensitometry are the exposure to the film and the percentage of light transmitted through the processed film. So this was first used as a tool for measurement by two British photographers in 1980. These are Ferdinand Herter and Vero Charles Dreyfus. Yung Dreyfus niya, walang E dun sa LED, okay? So, Ferdinand Herter and Vero Charles Dreyfus. Wala tong E. So, characteristic curve also called H&D curve, D log E, response curve, or sensitometric curve. So, as we've said, two principal measurements involved in sensitometry are the exposure to the film and the percentage of light transmitted through the processed film. Pag sinabi nating sensitometry, it is the study of relationship between the intensity of exposure of the film and the blackness after processing. Again, sensitometry is the study of relationship between the intensity of exposure of the film and the blackness after processing. Okay. So the basis of density or the basis of sensitometry is the density, and it has a log value of 0 to 4. So in this sensitometry have this formula where D is equals to log sub 10 times initial intensity over initial time. So light transmission, sensitometry is all about the light transmission, where an increased in density will have a lower light transmitted. Again, when we say light transmission, when we see a higher density on the radiograph, therefore the transmission of light is lower. Kasi mas dense yung radiograph mo. May magpapass through pa ba na light doon? Mas mababa yung chance. Pero may magpapass. But there is a lower chance of the light to transmit from a higher density radiograph. X-ray film has an inherent base plus fog density level of 0.2. Base plus fog density level of 0.2. Itong 0.2 na to is inherent on the film. X-ray film has an inherent base plus fog density level of 0.2. O, diba yan? X-ray film has an inherent base plus fog density level of 0.2. So, when plotting a characteristic curve, there should be a 0.2 automatic level on the density, because that 0.2 is already inherent on your film. So when plotting a characteristic curve, we need materials. So first is aluminum step wedge, or also called the penetrometer. Aluminum step wedge, or also called the penetrometer. This is a device made up of aluminum with copper base that is shaped like a step wedge, precisely calibrated to produce an exact and regular increase or decrease in exposure. So aluminum step wedge, it looks like a stair, a mini stair. And according to different steps, it has a different density that requires a different technical factor for exposing on the different steps. So what happens on a characteristic curve plotting is the radiographer should expose an aluminum step wedge as your first step. So once you're done with exposing an aluminum step wedge or the penetrometer, we will be needing a sensitometer. It is an exposure device which prints a pre-exposed negative directly onto the film and recommended for exposing strips for daily evaluations of the processing sensitometer. Okay, again, after you have exposed the aluminum step wedge, there is another material that you can use to have a printed pre-exposed negative directly onto the film. So that is your sensitometer. If you don't have step wedge, you can use sensitometer. But your densitometer is the device that you will use to measure the optical density of a portion of an image using a 0 to 4 scale. Okay? So I'm sorry, if you don't have aluminum step wedge, you can use sensitometer. But both of the end products from your aluminum step wedge and sensitometer should be measured using the densitometer. It is a device that will measure your optical density on a portion of the image using a 0 to 4 scale. So after measuring, you can plot the characteristic curve. On your vertical axis, that is your optical density. So as you can see, you start at 0 and ends up to 4 because that is only the measurement that your densitometer can provide. Diba sabi natin, portion of an image is measured by densitometer using a 0 to 4 scale. So that is your optical density. Below is your log relative exposure. The horizontal line. The line below. That will represent the amount of exposure the film received to produce a density. Your vertical or y-axis, which is the optical density, will represent the density reading obtained by the use of a densitometer. Your x-axis, or the horizontal line, it will represent the amount of exposure the film received to produce a density. So exposure is expressed as a logarithm of relative exposure. So the formula of D is equals to log 10 times I sub O over I sub T is the formula that you will have to use to determine your log relative exposure. We know that we have a base plus FOT. So you have to start at 0.2 optical density before plotting your curve. Base plus fog should be included in your plotting. That's the point where you should start your curve. What is the value of base plus fog? 0.2. So it should not exceed 0.25. It ranges approximately 0.18 to 0.23. Your base plus fog ranges approximately 0.18 to 0.23, but it should not exceed 0.25. Okay. So D max is the highest point curve. Let's see kung meron tayo dito. Wala. So using this curve, this is where your Dmax as in maximum density. Dmax is your highest point on the curve. The toe portion, the D-mean, is the first measurement above the base plus fog. So here is your D-mean. Measurement above the base plus fog. The first measurement. The toe portion of the curve represents an area of underexposure on the film. It provides little information because the amount of density is too small for an information to be evaluated by the human eye. The shoulder portion identifies the maximum density levels on the film and represents an area of overexposure. The contrast is minimum. Again, contrast is minimum in the shoulder and toe region, therefore making almost no detail visible. This represents your overexposure. This represents your underexposure. Therefore, there is minimal contrast in the shoulder and toe region. The straight light portion represents increase in density as the relative exposure increases. Higher straight line, it means there is a higher linear response. It begins at the level of approximately 0.4 density to about 2.5 above base fog. So the straight light portion starts or begins at the level of 0.4 density to about 2.5 above base fog. So, di ba meron tayong 0.2 na base fog, magsa-start lang ang straight line portion if it will attain 0.4 up to 2.5 above the base fog. There is a region of solarization. Region of solarization is the density on the film that begins to decrease with increases in exposure. So, dito sa part na to, this is your region of solarization. Once it reaches its maximum density, bumababa yan. Even na-reach nyo yung maximum na log relative exposure. Even there is an increase in exposure. So, it is caused by the shoulder, by the straight line portion. Region solarization is caused by the silver halide grain not being able to absorb any more energy and the grain beginning to reassociate into the silver bromide. hindi na kayang i-contain ng ating silver halide yung density, yung energy na ibinibigay nung ating exposure, hindi na niya kayang i-absorb, so that the grain will begin to reassociate into silver bromide. So once na nangyari yon, the density will decrease. Hindi na kayang i-accommodate lahat-lahat ng ating silver halide, yung energy na ibinibigay natin. Hindi na siya magkakaroon ng density. Magdi-decrease na siya. So that is your region of solarization. So on a straight line portion, tanggalin muna natin itong mga drawing. So, sa straight line portion, may mga parts pa din yan. May tinatawag tayo na film gamma. Okay, so film gamma is the maximum slope of the curve. It is measured at the steepest point on the straight line portion. Again, measured at the steepest point on the straight line portion. It is used to measure the gradient. An average film gamma is exposed X-ray film from 2.0 to 3.5. That is your average film gamma. Average film gamma is exposed X-ray film from 2.0 to 3.5. Film gamma is the maximum slope of the curve. Again, it is measured at the steepest point on the straight line portion. This film gamma measures the gradient. So, ano po yung gradient? Gradient is a slope at any point on the curve and will represent the contrast of the film at a specific density level. Again, gradient is a slope at any point on the curve and it will represent the contrast of the film at a specific density level. So, may tinatawag tayong average gradient. Pag sinabing average gradient, that is the measure of the contrast. Average gradient can be seen at the slope of the straight line portion between 0.25 to 2.0. Average gradient is where the slope of the straight line portion between 0.25 to 2. Average gradient. This measures the contrast. Okay? Yan, that is the straight line portion. Ayan yung makikita nyo in your straight line portion. Now, we have to evaluate or how to evaluate the contrast. So, sensitometrically, it is described by the average gradient or slope of the straight line portion of the curve. So, the measurements used to describe contrast are the film gamma, gradient, and average gradient. Saan nga makikita tong tatlo? Sa straight line portion. Average gradient